Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about piggybacking and HDLC protocol in computer networks. These two topics comes under data link layer. Today, we are going to discussing about piggybacking at the same time HDLC protocols in data link layer. First, let us see the overview of today's session. First, we will discuss about what is piggybacking. And next we will discussing about why do we need piggybacking. And next we have to discuss about what is HDLC protocol, that is high level data link control protocol in data link layer, that we have to see now. Next we have to discuss what is HDLC frame format, how to write the frame format using HDLC, that we have to know today's concept. First let us see what is piggybacking. Piggybacking is nothing but it is a process of attaching the acknowledgement with the data packet to be sent. So, with this what we understand, we have to attach the acknowledgement. Where we have to attach the acknowledgement? See here host A is there, host B is there. There are two types of host is there. Means here is the sender, here is the receiver. Sender and receiver. So, sender wants to send some data. So, I am sending the data. So, here the process of attaching the acknowledgement with the data packet means whenever after sending the data from the sender to the receiver, what the receiver has to do? He has to send some acknowledgement, right? Yes, I received the frame means data. Like that he has to give some acknowledgement. When we have to send the acknowledgement after, at the same time receiver also wants to send some data using from receiver to sender. Means ACK plus data. Along with the data, we have to send the acknowledgement. That is nothing but piggybacking. Suppose there are two-way communication, means sender also wants to send the data, at the same time receiver also wants to send the data. Then only that is called as a two-way communication between device A and device B, host A and host B. When the data frame is sent by A to B, then the device B will not send the acknowledgement. So, device B will not send the acknowledgement. So, until B does not have the next frame to transmit. Whenever the B is sending the next frame, then only it will send the acknowledgement. That is the piggybacking. The delayed acknowledgement, whatever delayed acknowledgement is there, that can be sent by B along with the data frame. Whenever the B wants to send the data, that time only acknowledgement will also come. That is delayed acknowledgement. The method of this attaching delayed acknowledgement with the sending data frame is called as piggybacking. Means with the acknowledgement, we have to send the data frame of the B. That is nothing but piggybacking. So, why do we need piggybacking? Why we have to send this piggybacking technique? See here, all other protocols in previous session we discussed stop and wait protocol, go back and protocol. These all are half duplex way communication. Means only one way communication. Only sender is sending the data. Receiver only what receiver will do? Only he is giving the acknowledgement. Sender is sending the data, but only receiver giving the acknowledgement is nothing but half duplex communication. But in real world scenario, full duplex communication is going to be required. So that reason we are going to use the piggybacking technique. It is having the full duplex communication. Means sender is also sending the data, at the same time receiver is also sending the data. That is the two-way communication. The TCP packets, transmission control protocol packets, are transmitting the full duplex mode. Means whatever TCP packets are there, those packets can be used for full duplex mode. So, this piggybacking is also needed. TCP packet transmission means the data is sending from the sender as well as the data is sending from the receiver also. That is the full duplex communication. This full duplex communication, we need both communications. A pair of simplex communication means for sending, there is a forward channel. If you want to send the data from sender to receiver, that is a forward channel. For receiving, so the backward channel is there for every link. That is the piggybacking. So, if we use this, means sender is and receiver both are sending the data. Means there may be configuration. The configuration means the traffic load become double because we are sending both the sides. That's why the traffic load becomes the double. So that the half of the data transmission only for acknowledgement of the transmission. If we send, suppose if sender is sending, sender also receiver also gives the acknowledgement. If the receiver also sending the data, sender also giving the acknowledgement. There may be chance of. So here the Data transmission is only for the acknowledgement is very high. Means if you transfer the acknowledgement again and again, there may be chance of traffic load becomes a double. That's why we are going to use the piggybacking technique. So with these piggybacking techniques, for better utilization of the network bandwidth, we are going to use this technique. So whatever the delayed acknowledgement means, whenever receiver wants to send the data, that time only we are sending the acknowledgement to the sender. That is piggybacking, means with that data frame only we are sending the delayed acknowledgement until there is not any data frame to be transferred. Then only we have to transfer the data from the receiver to the sender. That is called as the piggybacking technique. So next we will discuss about what is HDLC protocol. HDLC is high level data link control protocol. So this high level data link control protocol is, it simply views the frame. It simply views the frame as a collection of the bits. Means frame, what frame is contained, this is the frame, right? What frame is contained, frame exactly contains bits only. Here is the bits. Means simply views the frame, it is a collection of the bits. It is a bit oriented protocol. HDLC is a bit oriented protocol. HDLC is talking about, it is a high level data link control protocol. So in previously this HDLC is called as a SDLC, that means synchronous data link control protocol. So it is developed by IBM. It is the example of the bit oriented protocol. Previously it is called as the SDLC. This SDLC later is standardized by ISO, International Standard Organization. Then that time it is called as a HDLC protocol, that is high level data link control protocol. See how exactly frame format is there in HDLC, we will see now. So this is the HDLC frame format. See here, this is the picture for HDLC frame format. Here is the beginning sequence, here is the ending sequence. Beginning and ending sequence. Here the beginning sequence is having the 8 bits. At the same time, ending sequence is also having the 8 bits. 8 bit means this is the beginning and ending sequence. Means total bits how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 bits frame for the beginning and ending sequence. And the next what is there? Here header, body and CRC is there. So this sequence, what is the exactly use for the sequence? This sequence is transmitted during any times. At the same time, this link is going to be ideal so that the sender and receiver can keep their clocks synchronized. That is about the sequence, beginning and ending sequence. And coming to header, what is the header work here? Header is talking about the address and control field. What is the exact address of the particular device? That is the address and control field. How to control the field means how the flow control is going on, that is comes under the control field. And next one, body. What body is going to say? Here is the body. So it is saying about the payload, means variable size, means whatever data is going to be sending, that is going to be talking in this body. And coming to CRC, what is CRC? CRC in previous sessions already we discussed in error control, right? CRC is for error detection technique. This is the one of the error detection technique, CRC, cyclic redundancy check. For detecting the errors, we are going to use this CRC, right? That is can be used for 16 bits. These 16 bits for what purpose? For detecting the errors. So header is also having how many bits? Total 16 bits for address field as well as the control field. This is the header frame format of the HDLC protocol. HDLC is high level data link control protocol. So next, what are the different types of the HDLC frames? What are the different types here? There are the 3 types of the frames. Those are the I frame is there, at the same time S frame is there, at the same time U frame is there. What is I frame? I frame is talking about the information frame, and the S frame is talking about supervisory frame, and the next U frame is talking about the unnumbered frame. I means information, S means supervisory, and U means unnumbered frame. These are the 3 types of frames in HDLC. So what is I frame is talking about? I is nothing but information frame. I is talking about I frame is nothing but information. First bit is going to be 0. Whatever first bit we are writing, that is going to be 0. That is I frame. And coming to S frame. What is S frame here? S frame is supervisory frame. Means first 2 bits. Whatever first 2 bits are there, those are can be 1, 0. Whatever first 2 bits, those are 1 and 0. And next one, U frame. U frame is talking about unnumbered frame. Unnumbered frame means there is no numbering, means first 2 bits. Whatever first 2 bits are there, those are we can write as a 1, 1. Means here in iframe we are going to talking about only first bit we have to allocate for the 0, and in S frame we have to allocate for first 2 bits for 1 and 0, and next in U frame we are going to allocate first 2 bits for 1 1. So then these frames are called as a I frame, S frame and U frame in the HDLC, means high level data link control protocol. These are the different frames we are going to use in HDLC. And next, coming to today's summary, today's session we discussed what is piggybacking, where exactly we are using. Piggybacking means what exactly? Whatever data is sending from the sender. Whatever data is sending from the sender, here is okay. Data is sending from the sender, then receiver has to what? Receiver has to do? He has to do the acknowledgement. So, but he is not doing the sending the acknowledgement to the sender. So, whenever he wants to send the data, whenever receiver wants to send the data, then only the acknowledgement is also sending to the sender. Means along with the data only the acknowledgement is going to be sent to the sender. That is nothing but the piggybacking. And why we need exactly piggybacking means what? Discuss this is also right. What is exactly piggybacking? Where exactly we are using means for full duplex communication. For full duplex communication, we are going to use the piggybacking technique. HDLC is talking about what? High level data link control protocol. And we discussed what is HDLC frame format, what are the different frames are there like I frame, S frame and U frame are. These are the 3 frames we are using in HDLC format. These topics we discussed in today's. Okay. Thank you.